Hello everyone. In this video, so we are going to discuss about the some of the frequently asked questions in interview. So that is finding what is fanning, what is fan out, and what is noise margin. Okay, these are three different topics we'll discuss today. So this is mostly the frequently asked question in the interviews. So digital interviews or VLSI interviews or VLSI interviews, they will ask this is the most. So yeah, we'll just get into the topic now. So we'll first start with the fan in now. Okay, so consider if you have a system. Okay, so consider now you will have one logic gate only. So as we have discussed, so currently if this is AND gate, so while discussing this one itself, we were telling, right? So there could be 2 input AND gate or 3 input AND gate or 4 input AND gate, anything we can have. So the number of inputs we can have based on the cell what we are using. So the number of inputs could be anything. So generally the fan in is like this. It is defined as the number of inputs the particular cell can take and the particular gate can take from the external. Okay, so if it is an AND gate, if it is a 2 input AND gate, here you have to tell that fan in is 2 here. If it is a 3 input AND gate, your fan in will be 3. Okay, got it. So the number of input it could take at its input terminals. So the number of inputs it could take at its input terminal is called as fan in. Okay, this is simple as that. The fan in is just a number of inputs. How actually the number of inputs how we may have decided. So based on the internal logic it may have decided. So based on the lot of cell properties also it may have decided. So the number of inputs the particular cell or a particular gate could take is a fan in. Okay, then we'll talk about the fan out now. So fan out same as like that, right? So as per the thing you can come to know, okay, the output, but here we are not counting the number of outputs instead, but it is similar to that only. But fan is like if this is your AND gate, it is giving only one output, right? Always input could be any number of inputs, but output always will be one, right? With respect to the AND gate I'm talking about. Maybe some other system have number of outputs, but here we are talking about the particular gate or cell anything, so that will output only one output. So that one, if you see the fan out, how they are defining actually these things and all, right? The fan in, fan out and noise margin. So these are all some of the specification, logical or electrical specification that will come with the spec. Okay, so if you have one particular cell, you will be having the specification for that, right? So the specification documentation you will have. So in the documentation they will mention about the fan in, fan out or noise margin of the particular cell or gate what you are trying to use. So that they will mention that these things under the some of the things under the electrical specification, some of the things under the normal logical specification too. So here this fan out we have to talk about, right? So for that, consider generally what is the fan out means. So consider this is an AND gate means the identical AND gate, same property it should be having these AND gates. Okay, that is what the expectation here. So these are all ideal gates. So okay, so this is one AND gate. Consider this is a CMOS AND gate. So that time this also need to be a CMOS AND gates with the same technology node and all. Okay, so here if this is particular gate is driving all these 4, right? Drive. Okay, here we are talking about the drive strength of the particular AND gate, which is who is driving these gates. Okay, so driving strength mean as a basic electronics, right? As a basic electrical thing we already know, right? If the voltage source is here, okay, so if we have a multiple sources in parallel, we will be getting like this, right? The voltage terminal, the voltage between these terminal could be the same. If it is parallel, the same voltage will appear across these nodes, but the current will vary, right? Since the current need to be divided between these things, yeah, we call that drive strength. Since in the parallel circuit the voltage across the particular terminals will be same, but the current will vary because the current will based on the resistance of the particular path, the current will vary. Okay, current will get reduced also, it will get splitted, right, in the parallel circuit. So what I am trying to tell, so this is not enough, like okay, this voltage is there, for the parallel circuit, you may tell that this is a voltage is constant to the parallel circuit, right? Then why we need this one? So we need to have a particular, like if it is if it needs 1 milliamps current to drive this particular gate at the input. So this input may be anything, this input may be anything, but one of the input is driving from this means. So if it needs 1 millisecond as a drive strength, it needs, you have to drive, then it is identical, right? All are identical. So all need 1 milliamps, 1 milliamps, 1 milliamps. So you should be driving 4 milliamps, okay, to get all the things, to drive all the other gates. Then only you will be having. Then only you could feasibly drive all of these 4 things, right? So here fan out will be like 4 milliamps divided by 1 milliamps. The 4 milliamps is just, I'm assuming here, like this is the output, the output of this one. In the output it will be having the drive strength with the 4 milliamps current. So it is driving 4 gates, since each is having 1 milliamps as the current which is expecting at the drive strength which is expecting at the input terminal. It could all operate feasibly, so we can just tell that this is the 4, fan out is 4 here, since we can connect 4 identical gates at the output of the thing, okay? So I am telling this current things, right? So how these current values will be mentioned in the specification, that I will tell you. Okay, so generally this is the fan out one, okay? So how much current it is driving, that this is how much suffice to drive the gates, okay, the number of gates. So how much number of gates it could be able to drive, like without any functionality difference. So that is what the fan out, okay? So here 4 milliamps, since it's expecting 1 milliamps, we could drive 4 gates. If it's expecting 1.5 means, so that time definitely we don't have 4.5 itself. So it may have ended up only with the 2 gates. Got it, right? So yeah, maybe we'll go with that one, okay? I will tell you the terms now. Maybe for the next one also we may need. So let me just tell you that, okay? So generally, okay, I'll explain you those things. Consider, okay, we'll complete first the fan out. It's like there will be, in the specification there will be something, okay? IOH, IOL, IIH, IIL. Actually, these are all some of the current related specification which you could see in a specification of any other cells what you have your device, right? So something like that. So for that you may see these values actually. So generally what it defines, this particular IOH, right? It is telling that amount of current it is flowing through the particular output terminal. Okay, this is out, right? Flowing, this O means out, okay? So the O means O indicating out and this H indicating high. So that amount of current is flowing through the output terminal when your output is high. Yeah, as a logical term we can say this can be low or high, right? So how much current it is flowing through the output terminal when the output is high is this one. Okay, consider, we'll put an example here. This may be 4 milliseconds. We'll just take for our calculation purposes, okay? Same, if you see this is out, to mention the output, this is load. This is like amount of current flowing through the output terminal when your output is low. Okay, consider this is 1 millisecond. Okay, this is like IIH, right? So this is, as I am telling, this is mentioning this as input and this is high. So what this is telling, this is expecting, this is actually the expectation here. So this is what the input terminal, this is amount of current the input terminal is expecting when you are trying to drive high value at the input from the external side. So if you see your input, this is your AND gate, right? So here you are trying to give as a logical side, you are trying to give as a high, okay? So voltage will be connected to VDD. So that time your resistance across this particular terminal, right? So how it should match? It should be in such a way that it should match the IIH current. So this at least this is like at least it should be IAH. It can be more than that, but there also will be having some restriction there based on the electrical overstress and all, right? So that and all we should not be having, but this is IAH should be here in order to make to feel that particular gate as this input as high. Then only it will feel this input as high. Okay, then it will work accordingly, or otherwise it won't. So we should be ensuring that the IAH current needs to be flow through this when your input is high. That is the IAH. Okay, so this is input and this is okay. This is IAH. It's the same, right? You can itself guess. So this is low. So this is the amount of current the input terminal will expect to sense this input as 0. Okay, since we are driving low, right? So it is the expectation of the input terminal like to sense this input as 0. So this is what the expectation from here. Okay, okay, so this is about IAH, IAO. Okay, so now we can come to one conclusion, right? Or we can come to one formula like, so at the output side how much we have, because I told already, right, this identical gate should be. So if you consider this is an AND gate specification, so this AND gate IOH should be the fan out expression how we can write IOH divided by IAH, or same we can write for low also, right? So IOL divided by IAL. So how much output it can drive and how much input current it needs. So that is divided by this. This is or this one. This is for high, right? So this is for low. So generally we should be having all the things right. So generally if you, yeah, I will write here clearly. So generally how we will write, okay, so this is the fan out we were talking about, right? So this fan out is like, so minimum of, because we should be ensuring the functionality properly, right? Both in both this one or this one, low, this both what is that, both high and low conditions, it should be work feasibly, right? So for that we should be expecting this as in both the condition IOL, IIL, minimum of anything, minimum of these two. Okay, so fan out is minimum of, because like if we put max of, what it will do, it won't work for worst case, right? So what we have to expect here is comma VOL divided by, sorry, I'm talking about fan out, right? Sorry for that. So it should be IOH divided by IIH, comma IOL by IIL. Okay, so minimum of this one. So since we have to ensure both the values, right, high as well as low, in both the condition we have to mention the fan out, we have to make sure that thing is fine, working fine. So we have to choose the minimum of the value. So this is about the fan out. Okay, so the specification you will get from the specification of the particular device as well what you are working on. From there you will get the specification. So from that you can calculate the fan out of that. Okay, okay, now let's move to noise margin. Okay, so okay, noise margin we will talk about now. Okay, so noise margin is like I'll explain. So see, same as that only, one thing we have to know. Okay, generally what we see, only 0 and high. That is what generally we see, right? Consider your VDD is 5 volt. Like what we are calling as high is 5 volt and what we are calling here as ground. So we can't assure, right? Always this will be 0 as and 1 in the practical scenarios. In logical scenario, we will tell this logical 0 or 1, and in the voltage in case of voltages where we are explaining that, we will tell that as 0 or 5 volt. But in practical scenario, it won't be the scenario, right? So for that we have to be like we are having some range of voltages or range of voltages to tell that this same like that, like the current we are telling, no, same like that there is some voltage specification on the particular input terminal or output terminal of the particular cell, that it will expect some range of voltages to sense that as high or low. Okay, so that we are calling it now VOH, VIH, VAH, same like that. Okay, Consider this is your output, okay. So to make this as high, this will be VOH, this will be VOL, this will be VIL, this will be VIH, okay. Why I am telling? Consider this is one AND gate, its output is driving to one input of this AND gate, okay. This is coming from some ground or something. If you don't consider that, but you consider anywhere it is coming, but this is for the explanation we take, okay. So now this VOH, right? So same, both are identical gates only here also. So we'll talk about that. Currently we'll talk about that. To consider this is VOH of this particular cell and this is VIH of this particular cell. If it could be anything. It's like, consider this is 3.3 volt and this is 0 volt, 0.2 volt, consider, okay, VOL. What it is telling to us, like 0 to, sorry, so VOL is 0.2 volt, VOH is 3.3 volt. So what it is telling, it is telling that 0 to 1, 0 to 0.1, 0.2, if we drive, when we will give the 0 to 0. Since I am mentioning at the output, right? So here also same output and L means low. It is telling that while I am driving the output as low, my voltage could be vary from 0 to 0.2. It could be anything between the 0 to 0.2. Okay, it need not to be always the pure 0. It could be 0 to 0.2 while I am driving the digital low. Okay. So this is what it is telling from the specification. Same as here, I will drive my output between, okay, between 3.35 to 3.3 to 5. This is because of some electrical loss and all it will happen. So what I am trying to tell through the specification, while I am giving output as high, my voltage may vary from 3.3 to 5 volt. This is what my specification. So you connect input accordingly. So what it means, definitely if I drive 3.3 volt, you should be sensing that as high. If you see this is some logic family CMOS and if you connect some other family TTL here, it won't match, right? It will expect 3.3, it will out only 3.3 for a high. That time if it is expecting 4 volt means what it will happen? It won't sense that as high, but this is expecting it as high. But in between this thing, right? Yeah, I'll come to that. Yeah, but this is the scenario, right? You got it now. So like how in case of output high to high, the OL means if it is like OL max, right? Max, why I am telling, because 0 is my minimum value. I can give to 0 to 0.2 to make my output low. Same in case of VOH1, I won't call it as max, I will call it as min. Since my max value will be, still it could be 5 volt. So minimum it could be 3.3 volt. To make my, when I am driving my output as high, I will make this as 3.3 volt. Okay, so this is what VOH min will call, always VOL max will call. Same as the case, at the input side, I will be expecting this much to 5 volt for my high. Same as that case, VIH to 0 to VIL, I will expect at my input to sense that as low. Okay, so here also it will be min and here it will be max. Okay, oh sorry, this here it will be min and here it will be max. Okay, same like that. Use max value could be this one and minimum value could be this one to make this as, to sense this as high. This is what the expectation. Okay, now we got, consider you here this is 3.3 volt. Okay, so what should be the expectation here? You think about that. 3.3 I am driving already and max I could drive 5. So if you go high 5 volt, if you give, it won't be the problem. 3.3, consider this is 2 volt. Okay, so 2 volt itself it is sensing that as high. So what it is trying to tell, 2 to 5 it is considering this as a high. Here it is 3.3 to 5. So anyway I will be driving from 3.3 to 5 only. So that time maybe if there is any loss also, it can go up to some consider maybe 0.3 volt also, it's too high. Consider this is 1.1 volt reduced also, 3.2 it go. So that time also it can sustain that functionality because its margin is 2 volt, right? So here what I'm trying to tell, it should be in case of H scenario, okay. So VIH should be less than VOH. This is why I am telling, since this is the minimum value we are talking about, okay, since this is a minimum, it can go up to anything, okay. So the minimum value we should be covering. Maximum value anyway it will take 5 volt, means it will take the 5 volt, but minimum value we should be covering. So VIH, okay, so VIH should be less than VOH. So if you think about the low condition, just it will be VIL should be greater than, because it should sustain on the maximum voltages. It should sustain on the minimum voltages, because in maximum, here the maximum is not at all the concern, because it could come, the 5 volt if it comes it will take, but the minimum value less than this only it can't. So VIH should be less than VOH and VIL should be greater than VOL. This is the generally the condition or guidelines we may have given with. Okay, now then okay, we are good with all the definitions, right? So this is what, so here what is the noise margin, right? Now we have to, and one more thing, if one more thing, here it is VOH, right? So here it is VOL. So now this place, right? So if this voltage of any output voltage, or if the input which is reaching this gate because of some of the gate delays, wire delays and all, so that time this, if it does fall under this particular range, it will enter into the metastability. Okay, it will enter into the metastability. That's why if someone is asking you a question like what is metastability, so in your input you can't able to finalize that as a high or low, since it's not under this particular expectation. It is not under the particular our expectation, VOH or VIH, it is not under that. So this is our noise margin. So we can't, this is the metastability space. So where we can't able to decide this, whether this is high or low at the any time. Okay, so what is our rule now? VIH should be less than VOH to accommodate the wire losses, because from the output of the initial gate to input of the second gate, and VIL should be greater than VOL in order to make if any voltage ramps happen in between that. Okay, because this is the max value we are talking about, and this is the min value we are talking about. Max here it will be 5 volt, here min it will be 0 volt. So that we are facing no issue. So generally the noise margin is, as we see, in case of high it will be VIH by minus VOH, because it should be higher. It should be VIH minus VIH, because our VIH should be less than enough to capture the losses there. With respect to this one, we should be writing that VIL minus VOL. It should be large enough to capture the ramp ups on the voltage levels of here. Okay, so this is how we could tell that as noise margin. Yeah, I think you're clear. Thank you.